Hello, so we are going to show you a more advanced feature of the tool now, especially the wizard for templating or creating templates, preparing the sample management of experiment. So let's go to the main menu, create a new study, and select Use Expert Assistance. So this is a kind of tool that will rely on information about the experimental design to attempt to template and produce a template for you to use and automate annotation as much as we can. So let's say we have one study. You can already see the progress bar on the top. We're just at the beginning. Click Next. This is the main study. We provide a study ID, a title, my talk study, and some description of the experiment. Here we can provide the information about so let's say we are working on musculus using ontology. We search for this one and we find just this one we want to work on and select the value here. Then, how many study groups? By study group, we understand here treatment groups possibly. Let's say we have 6 treatment groups and we would like to have 10 animal per group. And we'll be dealing with a toxic exposure or chemical exposure. So we will have a compound, we will have a dose, and we will have a duration or time post-exposure. So this is compound. We can just duplicate this information. Here, this is a categorization that needs to be automated for the future version. Time, okay. And now we provide the factor levels. So for the compound, we will say have 2 compounds that we can provide in the tool by using a semicolon as a separator. So let's say aspirin and ibuprofen. Okay. And okay. For the dose, we need to provide a discretized level so that we can the engine can work. So here we provide high dose semicolon as a separator and low dose. Okay, and then at the time we can use 24 and 72 hours, short time point, and for the ontology we can use we will use hour. It's free text to go quick here. We can copy and paste the information here, and that's it. So I owe you a couple of information here. The reason, the way the things work is that it relies on the assumption that your experiment is type factorial design and the dose or the factor levels have been discretized, which essentially means that we will be using a Cartesian product of the individual factor level values to compute the number of treatment groups, the maximum number of theoretical treatment groups. So in this case, we should have 8 treatment groups. We have declared 6. Bear this in mind. So now we have somehow declared the independent variables. We need to declare the response variables. So we will be using, let's say, metabolite profiling using NMR spectroscopy and maybe a Bruker platform. We give an assay name, we create the assay, and then we will be exploring the transcriptome of these elements using Affymetrix platform and create this second assay. Okay. And click Next. So this is a summary of the information. We've got at the moment computed 8 treatment groups as expected with a number of replicates. So this screen shows the number of treatment groups with a number of replicates for each of them. As you remember, so the theoretical number is 8 treatment groups owing to the factor levels that we have defined, but we have declared only 6, so we need to remove the one that we don't use. So maybe we didn't use the low dose groups. For this for ibuprofen low dose and aspirin low dose, these were not useful. And for the other guys, we can also alter the number of replicates. Maybe some of the groups, the high dose animal, eventually were reduced for ethical reasons. But let's keep it to the same level. Progress. So the next step is to define the assays, as you can see in the progress bar. And at this stage, we need to tell the tool which samples were used to provide as input material to the assays. So for the material profile, we can say we had urine, for instance, and maybe add another one, which would be, okay, we have plasma. We can also specify that some of them were pooled or not, as people. The terms can be also looked up, because everything is modular in the tool, from the element. From the ontology lookup, we've got Brenda, we could select these kind of things. So in this instance, the information would be tagged with an ontology term. So let's avoid free text and look for urine in that particular resource. Let's find here, we select the term and OK it. Now let's go for microarrays section. So we use biotin because it's a matrix assay. We have RNA from liver and possibly kidney as primary target. We used mus musculus, so we need to detect which array is most relevant. It takes a bit of time. This one, cheap, and we can, as you can see, add more, as many as you need. And again, you can specify whether things have been pooled or not. So the tool has completed its task, and we can review and have a review of the treatment groups. This is what we expect, and the same is true for this other transcription. As you can see, these components, this is familiar. I've already showed these components, but in terms of software engineering, it shows that everything can be called from other different modules. And now we can finish. Progress is done, and we end up in this place, which is the ISAcreator normal view with all the elements that have been generated with this pattern, depending on, so automatically generated identifiers. The annotation here is available for ontology tag with mus musculus and BFO. Brenda tissue ontology has been used. And plasma was a free text. And there you go. You've got pretty much very basic information, but key information about your experimental design, and you can start inputting the key or filling up the gaps. Maybe you need now to connect to the files and provide maybe individual values for which instrument were used. So, interestingly, usually people have to associate a file to the particular record. And here we've got a specific file chooser that allows you to navigate either local disk, local location on a disk, and have them sorted by extension. But you can also connect to remote location using this FTP protocol at the moment, and the information will be recorded and available for you next time. Another way to do it is to call, and it's only available from this field file of type file. You can copy and paste the full path to these elements and call the resolve file name function. So to show you how things work, let's do the following. We copy this file name here, and paste it into this cell. And now call the resolve file name. You just select the top folder, and the tool will automatically take the full path to the tool by matching the file name. And of course, this is an interesting feature when you have a lot of, instead of doing the copy and click and paste, you could paste, if you're sure of the mapping, this table with the corresponding identifiers and resolve the file name to your system and your file system. This works at the moment only on your local drives. We hope that to implement that in the future to be able to also access remote locations. And this feature is available for all the fields in ISA syntax format where you've got a file tag. So it's really good to remember that we've got the QR code generation capability, especially used in combination with the wizard when you have the possibility to really leverage information about the experimental design pattern. So typically, at the moment, we only support factorial design, full factorial design, but we hope to be able to implement the support of crossover design too in the future.